All right, questions 15 through 16. Let's take a look at these. I think I like these problems. Well, I think you will too. Well, maybe you won't, but I think they're good practice. Okay, so the substance is at its normal freezing point at time. Which time? Well, I guess I should read this first part. The graph shows the temperature of a pure substance that says heated at a constant rate in an open vessel at 1 atmosphere pressure. The substance changes from the solid to liquid to gas phase. Okay, guys, so heating is not always equal to temperature increase. Okay, and we can see that when we look at this graph because I'm heating it, but the temperature, because it's a straight line here, is keeping that same value. So it's not always equal to the temperature increase. Okay, so first one is the substance is at its normal freezing point at which time? So this is an interesting one. So freezing point is really like the, I guess you could say the freezing temperature, right? Now, whenever I'm freezing something, it's not yet frozen, right? So that would be like if I had maybe like a glass of water and, you know, some of it's starting to freeze, right? But some of it is still water, right? So I have this kind of frozen blob in here, but some of it's still water. So it's not really water or ice, right? If we assume this is like a closed system here, this is not really a solid or a liquid phase. It's like the in-between phase, right? And that's going to be what you're going to get at the freezing point until you wait for long enough, right? So that's going to occur at time t equals 2, where the temperature remains constant for a little while. So that's going to be answer choice B. Okay, so which of the following best describes what happens to substance between T4 and T5? So that's going to be this right here. Okay, so let's go ahead and write out our phases actually. So this right here is going to be our solid phase. Yeah, solid. This is going to be our liquid phase. And then this right here is our theoretical gas phase. So basically it looks like what they're doing here is they're just kind of heating up. Let me see if I can draw this out. They're basically heating up a pan, or no, heating up something, right? So here, sorry, this is my awesome drawing of them heating up the pan on the stove. Oh, actually, kind of turned out better than I was thinking. Try it again. All right, so that's fire. And what's happening is I'm getting all these little molecules that are starting to exit now because it's really, really hot. So notice that we still have liquid, but we also have these little gas molecules, right? Now, the problem is that it's neither the gas or the liquid phase because, again, we can assume that this is like its own little system, right? You know, basically, if it's its own system, then I can't consider these two separate entities, right? So the question is, oh, also look, an open vessel. So this is not a closed vessel. That's important in just a second. All right, so answer choice A, the molecules are leaving the liquid phase. They haven't left it yet, right? I mean, well, maybe, okay, this is a kind of a tricky problem. Let's look at the other ones. The solid and liquid phases, okay, we don't have any solid here, so that's out. Oops, I changed colors. I'll cross it out in green. Let's see, the vapor pressure of the substance is decreasing. Well, it could be. Sorry, my thing just glitched out there for a second. I mean, it could be, right? Let's see here. The vapor pressure of the substance, or sorry, the average intermolecular distance is decreasing. No, that would be if we were freezing it, right? And then it says the temperature of the substance is increasing. Well, actually, no, it's not increasing, right? It's remaining constant. So we have two choices here. We have either A or B. So we have the molecules are leaving the liquid phase, or the vapor pressure of the substance is decreasing. This is not true, right? If there was something covering this, then we would be gathering more molecules here. They would be more easily there, and that would actually increase the pressure, right? Because there's more molecules. So therefore, the correct answer is, in fact, A. The molecules are starting to leave the liquid phase. However, I cannot say that we have a full gas yet, right? Just that some of them have started to leave. Sorry, I don't know why I drew that. All right, guys, so correct answer is A. If you have any questions, feel free to comment below, and I'll catch you guys in the next video.